Hello everyone, and welcome to the Toro Autonomous Trimmer Project. Sprinkler heads and other infrastructure on golf courses often are overgrown with grass around the edges that causes decreased functionality. Currently, these edges are trimmed by hand by a worker, and there are often thousands of sprinkler heads on a single golf course, so this problem adds up and quickly becomes extremely expensive for golf courses to maintain. There is clearly an urgent need for an autonomous solution to this problem. Because this problem is so complicated, we broke it down into three subsystems: object detection, probe, and trimmer. By combining these three subsystems, we were able to create a prototype that can successfully identify edges of golf course infrastructure and trim them with speed and accuracy. Our general design is a 3-axis Cartesian gantry motion system. This stepper motor-driven system allows the trimmer head to access all overgrown parts of the sprinkler head. But before it can actually trim the infrastructure, it needs to locate it. Our object detection system is based around a camera that is pointed downwards onto the sprinkler head that provides both RGB data and depth data. It uses a neural network to decipher this data and create a mask of where the visible edges are. Once the object detection determines where the edges are, it transforms that location into a toolpath for both the probe and the trimmer head to follow. The design of the probe subsystem is a hinged, spring-loaded distance sensor. The distance is measured by a laser time-of-flight distance sensor between points 1 and 2 on the diagram. Its goal is to physically roll over the infrastructure and determine if the actual edges of the infrastructure are located beneath grass that the camera cannot see. Here, the probe can be seen in action following a toolpath and collecting distance data. A large spiked wheel is used so that the wheel will push through the grass and hit the hard infrastructure underneath it. Both distance and the gantry location where that respective distance occurred are recorded. The data collected is then analyzed by taking the derivative and finding local maxima and minima. These correspond to the edges. This edge data can then be used to optimize the trimmer toolpath. Our trimmer uses a high-speed motor with the axis of rotation pointing directly upwards. Mounted on the motor is a looped weed whip trimmer design. This design maximizes the accuracy of the cut and minimizes damage to the infrastructure. The trimmer design emphasizes modularity, meaning it can quickly and easily be swapped with a different head for different conditions. The loops are attached to sliding inserts for easy replaceability. Here, the trimmer can be seen following the toolpath generated by the object detection. It is quite similar to a CNC mill toolpath, cutting off little bits of grass on each pass of the tool. When it comes to accuracy, our design met all of the requirements. Object detection locates infrastructure and creates a toolpath that is extremely accurate, within 5 millimeters of the ideal path. The probe can collect additional topographic data, and the trimmer trims quickly and does no damage to infrastructure. Here is an image of an untrimmed sprinkler head, and the results of one pass of our autonomous trimmer. The machine had no previous knowledge of the shape of the sprinkler head or where it was located within the working space. This trim can be improved by doing multiple runs. We had a great time working on this project, but there is still a lot of work left to be done for future groups. Thank you for watching.